Hello everyone, welcome to this video by 𝐷𝐷𝐴. We continue our course on Python, and as we know, we are presently working on data structure and algorithms. So we have covered data structures part. In previous video, we talked about the linear search, right? So what is a linear search? So what happens? It is when you have a list like this and you have to explore through elements A, B, C, D, E, F, G, something like that. You do that linear search, and the time complexity of that is 9 because you are just going from 0 to n, like from here to here you're going, and you take one variable. Let's say you take so we used to like variables like for a in s, correct? So technically what are we doing? We this a variable, we are iterating from here to here to here to here, so it is only moving in one direction and once a time, so it is a linear approach. Now in this particular video we will be talking about the algorithm 2, which is little bit advanced, and it is used for advanced questions because this linear search does not work always. So linear search has complexities when it arrives to when you solve complex questions. For example, let us say I'll talk about that question here, that suppose you have a list here, okay? Now when you have to find triplets, or suppose you have to find cup pairs, or you have to find triplets, or you have to find like quadrats, like there this particular approach is not good because as the variables increases I, j, comma k, comma l, our time complexity will increase, and so it will move from O of n to O of n square to O of n cube and so on. I'll show this using an example just now, and there we actually use the two-pointer technique. Two-pointer technique is very effective in DSA, so you should absolutely focus on how it is done, what is the architecture of it, what is the intuition behind two-pointer technique. So let's dive in without wasting much time. Now we will go towards a question. First of all, let us say so let me just zoom in a little bit. Okay, so now if I go here and if I see that there's a question that there's an array and you have a target. So given a sorted array of integers, find two numbers such that they add up to a specific target number, and please return the indices of the two numbers. So you have an array and you have a target. You have to find two elements so that sum is equal to 9. So let me open a workbook. So how will we do here is that, let's say I copy it. So let's say I copy this thing from here. Okay, so I have an array, I have a target. Now what do I need to find? So 2, 7, 11, 15. So I have an array 2, 7, 11, 15. So let's first of all discuss here how are we going to do it. So we have an array is equal to 2, 7, 11, 15. Okay, and you are given a target, let's say that is equal to 9. Now assuming there is only one such pair, you have to find a pair. We know that there is only one pair which is summing to 9, that is this one. But this is a very small array. What if the array is very large and you don't know about numbers, right? How do you build a solution so that doesn't matter whatever is the array size, whatever is the target, you are able to identify those particular numbers. So if we go our traditional way, how we do it, which is also called the brute force method. I'll speak what do you mean by brute force. Brute force means the most basic method where you where time complexity is high. I mean, you go to the most basic level to solve a problem, right? So that is called brute force. The method that we have been using till now is generally called brute force. So how will you do that? Let's talk about the intuition about this. So you have this array, okay, 2, 7, 11, 15. 2, 7, 11, 15. And what you want to do is you want to find a pair. So you want to find a pair technically, that is a comma b, such that the sum a plus b is equal to 9. Okay, you want something like this. So you will need to have two initializer, two variables basically. uh, so you will need to have an I and you will need to have a j. Okay, and what you will do that you will so you will keep, for example, I fixed at some place, and you will for example, let's say I is equal to 2 here. Okay, let's say I is equal to 2, then j will take what values. J will 2 comma 2 is not possible because I and j have to be distinct, correct? So j can be 7, it can be 11, it can be 15. So there are three pairs like this: 2 7, 2 11, and 2 15. Okay, when I is equal to 7, what can be value of j? So j cannot, so I is equal to 7, it means that j can be so j cannot be 2. I mean 2 and 7, 7 and 2 we are considering same. So let's say j is equal to 11 and 15. Okay, so what will be my thing? It will be 7 11, and it will be 7 15. We can also take 7 2. I mean, that's, I'm not just including right now, but we can take that. Let's say I is equal to 11, then j can be 15. Okay, yeah, so let's take that as well. Let's take that 7 comma 2. Okay, and if I is equal to 11, j can be 15, j can be 2, uh, j can be 7. So again there are three sums. Okay, so that is possible: 11 comma 15, 11 comma 2, 11 comma 7. So what do we see? That for every I, j, and now when I put I equal to 15, again I will have three values. Okay, so what do I see? There are total three, three to four, total 12 possible cases. 12 operations are there. 12 operations will be there. Okay, so technically what we have to do, this is 4, if you know maths, it is 4c2, right? So uh 4 4 factor, so sorry, it will become 4p2, right? So that is the thing. 4p2 means 4 factorial divided by 2 factorial divided by 2 factorial, and something like, so it will come out to be total 12 operations we just saw. So what do we see here? That to get after this, what happens? We have 12 pairs. To each pair I will pass the condition: if a plus b is equal to 12, then print that pair. Okay, so for example, so this sorry, we need 9, not pair. So this seems fit to me. Okay, I'll one by one search everyone. I'll down, close this, close this, close this. uh this will make sense to me. Okay, and close this, and close this. So I will have only two pairs: 2 7 and 7 2. Okay, 2 7 and 7 2 will be meaning here. Now so what we did, we explored all the possible 2D combinations, and then we uh, then we put the filter, and then we selected. Okay, that's how we did it. Okay, after this you can just pass it to a set to get the value. The What is the problem with this particular thing? The problem with this is that when, as your array size increases, okay, your complexity increases. So first of all, let's do using this method. Let's solve this question using this. So suppose we have this array, right? Array, the same array that we just spoke about, and we have a target 9. Now we want to do it using the brute force method, which we generally do. So what will be my approach towards solving this particular question? So what I will do is that I have to find two elements whose sum comes out to be 9. So what I will do, I'll create two iterators, because I will have to store one number in, I have to get something like a b, right? So I need one iterator for a, one iterator for b, so that I can eventually check their sum. So what will be my first step? My first step will be to get all pairs. Okay, second will be to check pairs with sum 9. Okay, and I basically select those pairs which have sum equal to 9. So what I'm doing, I'm exploring all the possible pairs. and here we have 4. So how it will start, we will have to initiate two values, I and j. So what I will do for I in range, now I will vary from 0 to 3, 0 1 2 3 in range, and for that we can take length of ARR. Okay, because length of ARR will give me 4, uh, 1 2 3 4, and so it will be range of 4, means 0 to 3 it will go. And now on the next item, let's name it j. Now j will, if I is varying from this to this, now j will vary from this to this, because both cannot be same at any point of time. So for j in range 1 to length of ARR. Okay, or even you can do that, like let's say you don't, you want to keep it like this. For j in let's make it j even go from 0 to this point. Let's go even like further, more brute force, right? So what I have to do, I have to create uh, like an array like this, in which I will store values. So right now I'm getting all the pairs which I will be storing in there. So what I will do, res dot append, and if you know, in append we can only add one element. So what we will do, we will add ARR I comma ARR j. Okay, this is the slicing. Because I and j are what? They are indexes. They are not the actual values. They are the indexes. Okay, and so I close this. Now let's see what is a res coming out to be. Let's say I do print res. Okay, so I have got all the pairs 2 2 2 7, like so all the pairs which are present there, and I have even made I and j equal, so that I and j can be equal. Of course, there some will never be uh, come out to be 9, because 9 is an odd number. And of course, now what I need to know from this is that now I want to select those values of those lists out of the list of lists which have a sum equal to 9. So what I will do, and I will store them in a new. So let's name a final list, final equal to this. Now what I'm doing is for list in res. Okay, so what I'm doing now, if I see this list has two elements, 0 and 1. So if list of 0, okay, plus list of 1, if this is equal to 9. So what I have to do, if this is equal to 9, what I will do, final dot append, and I have to append list. So I have to append like this. Okay, inside this I will append two things. I'll first of all add list of 0 comma list of 1. Okay, and now let me print final. Print final. So if we see 2 7 and 7 2, so basically technically I mean they are same. Now we ideally we want only 2 7, but it depends. I mean whatever the pair is, we can eventually take a set of it. But we see that we have 2 7, we have got one pair from this through this method. But what is the problem with this method? So basically to avoid this, what we generally do is we have to make this vary from 1 to, so that the pairs do not contain the same values, right? Now if you do, you'll get 2 7. Now I have to know, okay, I'm able to get the value, the value of the index, the value of the number pairs which sum is 9. But what is the problem with this? The problem with this comes like this. Let me explain you what will be the eventual problem with this kind of method. This code is not optimized. The reason being, presently my array is of length 4. Okay, 1 2 3 4. I am initializing two values. I is varying from 0 to 3. It means it can take four values. And let's say if I'm making j vary from 0 to 3 as well, four values. Okay, so what is happening, the total operations are how much, is equal to I into j, and this is equal to 16. And so it is what time complexity, it is of complexity O n square, because there are four elements. So this is of time complexity O(n) square. And the problem with this is that as the array size increases, for example, you have an array of, let's say, 1000 elements. Okay, so your time complexity will increase. So if your 10,000, let's say if array has 1000 elements, okay, so 1000 into 1000, so it will become, total operations will become 10 raised to the power 6. Okay, uh, and although there are 1000 elements, but your 10, so there are 10 raised to the power 3 elements, and if you run using this method, it will be 10 raised to the power 6 operation or combinations, and this is not good. Anything beyond 10 raised to the power 9 is generally not considered good, and you have to test on like thousands or millions of possible like possible elements in an array. So this is not a good approach. Generally, ON or ON are the best approaches, so that you have to diverse only once. You don't, now imagine, now let's say there is a case of triplets. So what you will do, you will have I, J, K. Now let's say it can take 1000 values. It will also take 1000 values. It will also take 1000 values. So it will become 10 raised to the power 9 operations, and which is not good. 10 so many combinations. Okay, and this is not ideal for your computer system. So this code will not, at lot of websites, like if you go to lead code or some other, they will not accept this code, or even in interviews they will say, no, run me a code in time complexity ON, where you don't create two variables I and J, you create only one variable, or you traverse only once, or you traverse only once in the array. Okay, here what is happening, we are traveling two times. First I is traveling from 0 to 3, and then J is also traveling from 0 to 3, and they are doing at it a different point of time. That's why the time complexity increases. So a better method to solve this is called two pointer approach. So I will speak about two pointer approach now. So in the brute force method, we saw that we basically, when we have an array, right, and if we have to, for example, let's say we have to get two variables, three variables, four variables, my time complexity increases, because every time I introduce a new variable, I have to traverse that array that many times. For example, if there are two variables, I'll be traversing through my list two times, right? And therefore it become n square. If there are three, so ijk, so it will travel three times, and it will become n cube. Four times mean n raised to the power 4. Okay, so my objective is to solve something in complexity O raised to O n. That is, I only want to use one. So n doesn't mean one variable. N means you traverse through the array only once. Okay, so you either go through this once, or you either go through this once, right, or you come halfway here and halfway from here. So overall distance that you travel inside the array, that should be n only, right? So if there are n elements, it should travel only, there should only be n operations then only it's called ON. It has nothing to do with the number of IJK I am using. It has to do that how many times are you traversing inside the array. That is the main concept. Now let us understand the two pointer algorithm. The two pointer algorithm, basically it has multiple types. If I just show you the booklet, it has so let's come here. It's a technique, is a approach used to solve various problems in data structure and algorithms. It is specially used for problems involving array. Okay, the main idea is to two pointers to traverse the data structure, typically to find. So we have to traverse through the like whatever we have array here, and in this case we want to traverse only once, not multiple times. So there are three methods, there are three techniques of two pointer technique. In this video I'm just going to walk you through the basic one, which is when both pointers moving towards each other, right? So it is often used to find pairs that sum to a target value in a sorted array. And then there are some others as well, when one pointer is moving one, so so what if there are three types of cases, that you created this array. Okay, you created this array like this, and you have three methods. So first method is when so you have three methods to solve it. So your first iterator is here, your first iterator is here, is here and your second iterator is here. Okay, so let's say this, call this is I, this is j, and you move towards each other. Okay, this is called first method. This is called when two pointer technique, when both move towards each other. One is where I is stagnant here, okay, and another is j. J moves from here to here. In that case, I remains fixed at this point. We utilize it in some other method manner, but j moves from here to here. Okay, so that is the main thing. And the third thing approach is when both move, I and j both move from in one direction, right? And that is used in so if you see both pointers move in the same direction, commonly used in problems involving sliding windows. So that we will talk later when a little more advanced DSA comes in. So we are in this video we are focusing ourselves to the first case where both pointer move towards each other. Okay, so let me refresh the page and I'll walk you through how to build this. The first I'll walk you through the intuition behind this. So what happens? So let us say we have this array, right? 2, 7, 11 and 15. Okay, so how two pointer algorithm works here? This is 2, this is 7, this is 11, this is 15. Okay, this is my array. Remember the key target is to, I want to solve it using n complexity, means I have to travel to the through the whole array only once. Okay, only once. I don't want to travel multiple times. Okay, so that is my objective. So what I do is I create two variables. One, I create left, I assign it here it to 2. Okay, and then I create a right pointer. So I assign it to 15. So let's say the left I have named it I and right I have named it j. Okay, these are the two pointers that I have assigned. So what is the index value? So I will be equal to 0 and j will become equal to 0, 1, 2, 3. It will be 3, or you can say length of array minus 1, because we are talking from the end. I mean, this length can vary. So in general, this particular, this will be the first pointer and this will be the second pointer which we are using here. Okay, so now the main thing starts, that we have to iterate. So basically we have to iterate. What will eventually do, we have a condition that I, for example, array of I plus array of j, this has to be equal to 9, right? We know that we have to test it for this. Okay, we want to test it for this. So what will happen, there will be few scenarios when we will move. Sometimes we will move I here, sometimes we will move j here. Okay, so what will happen overall, either I will move till here and j will move till here to get the sum. Okay, so for example, in this particular case, the sum, we know that 2 and 7 are there. So what will be happening, I will remain here and j will traverse from here to here to here to here. Okay, so I didn't travel the whole, I traveled this part. I mean, technically it remained in this, and j traveled here. So combined I plus j, they traveled only n. That is the length of the array. So the number of operations remained to be n. Okay, now for example, let us say the sum they asked were 18. Let's say they asked for sum 18. So what will happen, I will traverse from here to, I will traverse from 2 to 7. Okay, and j will traverse from here to here. So again, I plus j combined, they have moved how much, equal to n only. So in any case, we are traversing from here to here, and maximum their sum is equal to n. So that's why this, whatever approach we are using, it will be of time complexity on. But how do we solve the question using this method? Oh, I understood that. Okay, let's say half, some distance I will move, some distance j will move towards it, and combining they will be forming a maximum step of n. But how do we ensure that sum is becoming to be equal to 9? So let's solve that thing as well. Okay, so let's start solving this once again. So let us say we had this array, right? We had this array which was equal to 2, 7, 11, and 15. Okay, we had this array. Now what we did, we initialized two pointers as we discussed. So one, this is my first pointer, which is I equal to 0, and this is my second pointer. This is j equal to 1 2 0 1 2 3 3, or you can also say it length of array minus 1. Okay, I have initialized two pointers now. So one will move from here to here and one will move from here to here. Okay, so we see that, and this is of time complexity on, as we discussed, because at any point of time they combine will not move more than 4, because either it will move here and it will move here and then they will meet here, or they will meet here, something like this will happen. Okay, we have to make sure that we loop till they meet each other, till they meet with each other. So what is going to happen is that I will start this particular j from right, and suppose they are at this particular point, right? Now tell me, can j go beyond I, and can I cross j? So is that possible? That is not possible, because for example, let's say I is equal to 1, that is this, and j is equal to 2. If I say that j is equal to 1 and I is equal to 2, that is not possible. It is because it is an exact same replica of this, right? These and these two combinations are exactly same. Okay, so this is not possible. So we will loop this particular thing till left part, that is I, is less than j. So what will be my loop condition? So I'll start a while loop while my I, or left part, I say that is less than the right part, or you say that is while I is less than j. So this is a very important thing. Till this we will be executing our loop. So this is my first thing that you need to understand, why I and j cannot pass. It will move some steps here, it will move some steps here, they will meet at some point, but they cannot go past each other, because it will eventually meaning the same thing only. Okay, so combined I and j, as we saw, I plus j, they are moving n only, and that is why this is a n complexity. Now there are three scenarios. Okay, there will be total three scenarios which we need to address each of them. Scenario one. So let's discuss about. So what we'll do, basically we will create a sum always in. We'll create a sum that is equal to ARR I plus ARR j. Okay, we'll keep a track of their sum, where for example, let's say my iterator, my first pointer is here and my second pointer is here, or let's say something like that. So we'll always keep a track of their sum. Okay, for example, here it became 13. So at some place other, they will have some other values. Okay, and then I have a target sum which I want to achieve. Target is equal to 9 here. The question says target is equal to 9. Now there are total three scenarios possible. So I'll discuss them one by one. The first scenario is that your total sum is greater than target. Okay, so for example, in this case, 2 11, your sum is greater than target was 9. So what will you do? Eventually what will be happening, you have to either move this to the left, or you have to move this to the you have to move the left pointer to the right pointer, or you have to move right pointer to the left pointer. Okay, now tell me, if sum is greater than target, and we know that this scenario is only this array is sorted. So remember, this array, you have to sort this array always. Okay, from ascending to descending. Now if sum is greater than target, so what will you want to do? You will want to reduce the sum. of course, if you have to reach to the target. And how reducing sum is possible? You have to basically either decrease this or decrease this. So you have to either decrease this or decrease this. Now decreasing this is not possible because this is already in ascending order. So this can only move right and this can only move left. So if your sum is greater than target, what you will do, you will move, take your right value, take your right pointer, you will reduce this, you will move it to the left. Okay, this is your first scenario. Second scenario, if your sum is less than the target. Okay, we do not see that here, but what if your sum is less than the target? There you will move from left to left plus equal to 1. You do something like this. Let me explain you through a bigger example as well so that you understand it even further. So let us say there is an array. Okay, let's create a different array. So let's say there is an array 1, 4, 8, 3, and let's say 7 and 9. Okay, now we technically want that the sum of basically the sum of the 2 points. So let's place the target that we are looking for. Okay, so let the target be for example, so we have to think of a sum 8, 3, 11, 4. So let the target be 7. Okay, or let's say the target be for example 9 plus 7, 9 plus 7. We can make it, we can make the target for example 9 plus 7, 16. Okay, let's make the target 16. Okay, so the target is 16. Okay, so how will this thing function? Your I will start from here, I equal to 0, and your j is equal to 0, 1, 2, 3, 4, 5. J is equal to 5. Okay, so we will see what all steps we will be doing. Now the first step is to calculate the sum of a so what is the sum? ARR I plus ARR j. Okay, this is my sum. So in scenario 1, we have a sum and then we have a target, that is target is equal to 16. Okay, so let's see. So let's keep this as our sum. Okay, and this be our target. Now in scenario 1, when this is my I, this is my j, what is my sum? 1 plus 9, that is equal to 10. Okay, and my target is 16. So if we see that this particular sum is less than the target, so what do I need to do? I need to increase. So I need to increase this because 9 cannot be increased, so I'll have to increase this. So what I will do, I'll shift I from here to here. Okay, so I'll do I plus equal to 1, I equal to I plus 1. Now what becomes? Now my I value becomes 1. In second scenario, now what is my sum now? 4 plus 9, it is 13. Okay, here my sum is 13. Now is my target is still 16, it is still less than this. So what I will do, I will move my left pointer towards right once again. So I will do it here. Okay, so my I becomes equal to 2 here. Now when my I is equal to 3, what is my third sum? So 8 plus 9, that is 17. This becomes 17. Okay, and this is 16. So what do I see? That the sum, my sum value is greater than this. So what do I need to do? I need to reduce the number. So I will move 9 from here to here. Okay, and that's how it will function. Now my I is equal to 2, so my j will move from 5 to j will become equal to 4. Okay, now after this what will be happening? After this, similarly, depending upon the scenario, I will either move this to the left or this to the right. So this is what I'm saying. When my sum is greater, so when my sum is greater, I have to reduce the value. So I'll move from right to left, and if my sum is left, I'll move from left to right. So that is the thing. And what is my third scenario? When sum is equal to, when sum becomes equal to my target, that is the value that I need to store. Okay, there I need to store that particular value. This is called two pointer approach. So I try to explain in as much detail as possible. Now let me take the current example that we were doing, that we were doing here, that is 2 7 11 15. Okay, so this was, so that things are little bit easy to for you to guys to understand. 2 7 11 and 15. Okay, uh, we are ensuring that there is only one such sum possible right now. I'm not complicating the things. So for example, in the previous question, multiple sums were possible, multiple cases were possible, right? So I'm trying to explain through where there is only one pair, 2 7. So what we do, we start with this point I equal to 0. Okay, and this is j is equal to 3. Now what is my sum, my first sum? So my first scenario, my sum and my target, I will check. So what is my sum in the first? 15 plus 2 17. And what is my target? 9. So my sum is greater, so I have to reduce the value. So I will move j to here. Now my j becomes equal to 2. So what is my second sum? 11 plus 12 13. It is still less than target, so I will still move it towards right. Okay, and what is my third sum? My third sum is 9, and this is 9. And because these are equal, then I will stop. So basically I will store these two values in my list. And that is how you use two pointer approach to arrive at a solution. So I hope this theoretical explanation is clear. Now I will move towards the coding part. So we will come towards the coding part. Now here in coding part, what do we have? We have array equal to this and target equal to this, right? So we start the coding part. The first of all thing that we need to do, we need to define a left pointer. So let's say left pointer I is equal to 0, and the right pointer, that is j, is equal to length of arr minus 1, which is equal to 3. Okay, so now if I have got this part. Now I'll start with my looping condition. Remember, we have to loop till I is less than j. So while I is less than j, I loop this till that particular scenario. So if I do this, now what will now what will happen, that okay, while I is less than j. So we'll start the coding part. So first of all, we need to create a temporary sum. So temporary sum is equal to what? It is arr I plus arr j. I'm creating a temporary sum for everything. So after this, I will have three scenarios. So just like we discussed, we have three scenarios total that we will be discussing. The first scenario is when temporary sum is equal to target. So what do? We have to store that value. So what we will do, we'll create a simple blank array, and we will do rest dot append, and in this we will append my I comma j, that is the indices. I'll append. If I have a match, I will append there, and then I will break the code. Okay, then I will not move forward. Now what I have to do next? Elif. So remember, in Python, we if I have to use else if, we directly write elif. Now for elif, we have to write down if tmp, let's say the second condition will be if this sum is less than target. Okay, so let's go there. If my sum is less than target, for example, so what will I do? I'll move my left pointer. Okay, I'll move my left pointer towards right. So basically, because right now my sum is less than target, so it is lying somewhere around here, and something is here, so I have to increase that particular sum. To increase, I have to move that left from here to here. So I will do left plus equal to 1. So, or you can simple say I plus equal to 1. You can do like this. And the third condition will be when the sum is basically when your sum is greater. When your sum is greater, you have to move your right value towards, because you have to drop off value, because you have to drop the values, and you have to reduce the value. You have to move from here to here. And so what you will do, you will do j minus equal to 1. minus equal to 1, and now I will print res. So if we see that if we're printing, we are getting 0 1 0 or 1 are what? They are the indexes of this particular thing. So we can this is the syntax of that particular code, that we start with 2 pointer here with left pointer and then the right pointer. Then we iterate till while is like I is less than j, and then we create 3 scenarios. When one is when temporary sum is equal to target, which is our ideal scenario that we want. If such thing appears, we will basically return it in my array. Otherwise, if it is less, I will iterate towards right or left depending upon the scenario. If I want to increase the sum, I'll increase my left pointer, and if I move to reduce the sum, I'll move my right pointer towards left, and finally I'll print it. So this is the code part for this particular scenario, and this is called 2-pointer technique. So this is about this video. Now if you see, there are 2 assignments questions. One is where you have a difference, right, where you have to target is difference, and another is product. So these 2 questions are entirely based on this method only that we just discussed. So I want you guys to try this on your own, and this is your today's assignment, these 2 questions. Okay, so what I will do, I will just paste this particular code in the I'll paste this particular code here so that you guys can refer to it. Okay, and yeah, so that's about this particular video. This is called 2-pointer approach, where which it is used to reduce the time complexity. I actually tried my best to explain you, but still, if you guys don't understand, let me know. I'll try to come up with more explanation. This particular thing will come with time, to be honest, right? And that's why I just introduced this concept here so that you can try a couple of questions. This is the first question of 2-pointer technique. There are very advanced question of 2-pointer technique as well, but these are the first where you have to get 2 values where their sum is equal to something. So try using the approach that I told you, and let me know if you guys don't understand anything. And thanks again for watching the video. You guys are really doing great. It's been 2 weeks, and we are really lucky that you guys have thoroughly solved every assignment, every video you have watched. So we are grateful to you. Please keep learning, please keep doing things parallelly. DSA problems we have started now, and complexity will increase. So try your best, watch the video, understand, practice on your own, and let's repeat. Do this on a loop till 31st of August, and we will definitely see a rise in our Python level. So thanks again for taking out the time, and I will see you in the next video.